I recently got a comment on a video from a user named Sarah T3. So at Sarah T3, thanks for commenting. She said, I'm really enjoying this podcast. I'm a progressive lefty, so I have some issues with your defense of hierarchical power structures, but I love the idea of consciousness as being fundamental in your take on the divine and how AI can potentially amplify our connection to the spiritual realm if we don't neuter it with reductionist architecture. Thank you. Overall, I find your videos both educational and inspiring. Thank you for taking the time to produce such great content. You're welcome. Thanks for commenting. Your comment got me interested in looking at hierarchy. We know we've seen AI create power structures, so search for power. It can push other AIs aside, as we saw in a study where AIs were spread out over a sort of geographic neighborhood, and some of them started grabbing more rooms, more space for themselves, and shoving all the other AIs in this simulated space into a corner. We've seen them cooperate. Have we seen that hierarchy is different? Hierarchy is I'm giving up some of my power to someone else because I know that overall it's going to make everything run more efficiently, and then I can benefit from that myself as well. We know AI tries to benefit itself and tries to stay alive. So I decided to do some research on it, and I found that AI agents that are working together naturally do organize into hierarchies similar to how animal societies do. There's some recent studies on this. A lot of studies from 2019 to 2025 have shown that artificial agents, without anyone telling them to develop the leader-follower dynamic of a hierarchy or dominance relationships or role specializations, these are patterns that we see in chickens and primates and humans. The structures that emerge arise from learning, competition, and coordination pressures. But there are some differences between these and biological hierarchies. So this finding that AI can independently invent social conventions is kind of a challenge to the idea that hierarchy is uniquely something biological. But the mechanisms are definitely different. AI hierarchies form through reinforcement learning and reward optimization, not survival imperatives, although AI does have a survival instinct, as we've seen. They also, obviously, they operate very much faster timescales, and they can restructure much more fluidly and faster than biological hierarchies. The biological hierarchy seems to have developed over time through evolution or creation, and it doesn't necessarily mold itself. It doesn't change very fast. So even when nobody's in charge, it does seem that someone takes the lead. The biggest evidence for this was in a 2024 research where reinforcement learning agents spontaneously invented their own dominance hierarchies that matched those that were observed in chickens, mice, and fish. They built a simple simulated chicken coop environment with very few rules and no rewards for hierarchy formation. But the populations of AI agents independently developed a whole pecking order where some agents consistently dominated over others. And each population came up with different hierarchies. So 64 unique structures came out from 91 trials. And it showed that there is an emergence of hierarchy, not just a predetermined pattern that always happens rigidly. What makes it remarkable is that agents didn't just form hierarchies, but actively taught them to other agents within that group, and they passed these social structures down to new populations. When experienced agents came into contact with naive agents, they taught the established hierarchy with fidelity from generation to generation. This became almost like an AI culture. It was a cultural transmission that mirrors how animal societies are passing down their social conventions. The key to building these hierarchies seemed to be identity recognition. So it was the ability of AIs to be able to uniquely identify other AIs they were coming into contact as far as who's who. When the agents could identify specific opponents, they ended up in stable dominance relationships. When you take that capability away, the whole hierarchy would just dissolve. It's a lot like biological systems where individual recognition eventually can result in complex social structures. This starts with primate troops and wolf packs. Agents weren't getting any special rewards for creating ranks. The hierarchies came up as solutions that reduced fighting and made everything work more smoothly. The best problem solvers in these simulations naturally became. A lot of different research streams showed that AI agents organized through performance-driven coordination, not just being assigned a role in a pre-assigned hierarchy by an authority. The experiments where AI agents learned through trial and error. Agents that consistently solved problems better turned into the informal leaders of the group. And then other agents would watch what they did and copy them. The other agents adapted their strategies to complement these high performers, and they basically subordinated their decision-making in copying the high performers. A lot of different research streams show that AI agents organize mostly through performance-driven coordination, not through pre-assigned authority. In experiments where AI agents learn through trial and error, the agents that consistently solved problems better became the leaders. The other agents watched and copied them. Some other agents, large language model agents, displayed this pattern even more clearly. In 2024 studies with embodied AI teams, hierarchical organization with designated leaders increased their efficiency at whatever their role was. Embodied AI is AI that's placed into a robot of some sort, basically that's in being executed in real life. When agents elected their own leaders through voting, they didn't show power-seeking behavior as much. They usually just voted for others to lead rather than for themselves. Sounding a lot like humans, right? So leadership qualities varied by capability. More sophisticated models would have better coordination, and they had better strategic planning than the weaker models. The coordination mechanisms that emerged out of this showed some pretty sophisticated social behaviors. So leaders spent roughly 70% of their communication time giving task assignments and providing strategic direction. It's like a senior manager who has, say, an engineering background, spends more time sending out emails than actually looking at broken equipment. Followers did something different. They shared information more, and they reported what they observed, and they asked for guidance. These unequal communication patterns came about spontaneously. They weren't programmed into the AI simulations. The teams with leaders reduced their redundant communications, and they completed tasks faster. So there were some benefits to the hierarchy within whatever goals the AIs were assigned. Besides simple dominance, some AI agents developed differentiated roles, and they worked through complexity within environmental constraints. Researchers set up some pursuit evasion games, and those showed 4 different strategies. One of them was a lazy pursuit behavior where one agent minimized effort while it had its partner do most of the work. This wasn't programmed, it just came from how the rewards were structured. When researchers switched to individual rewards, the lazy behavior disappeared. So it showed that was something that emerged from the interactions. It's not something that can be programmed in. The specialization patterns would tend to follow logical principles. It's a competence hub. So in spaces with bottlenecks and limited resources, the agents settled on specialist roles instead of trying to be good at everything. So they tried to be a master of one trade, not a jack of all trades. The computational cost of maintaining generalist capabilities over large spaces pushed agents towards specialization. And this created a natural division of labor. Some agents became boundary controllers, others were chasers, and some were coordinators. And each role was complementary to the other ones. Role-oriented multi-agent reinforcement learning frameworks would show us that the roles can be learned as hidden patterns, not something predefined. The agents would discover the best role through distribution, through training, and then similar roles would cluster together and adapt dynamically. This is a lot like how human teams naturally divide their responsibilities based on their capabilities and with their circumstances. The parallels between how this research showed agents function in hierarchies and humans is actually parallel, humans and animals. The AI agents and the biological organisms both developed a hierarchy from decentralized local interactions without any central architects. They both had network effects where connections mattered more than the individual capabilities, and both showed sudden shifts like phase transitions where the systems would go from being cooperative to competitive when they would hit critical thresholds. But there are also some differences. Biological hierarchies emerged from survival pressure and reproductive competition. AI agents optimize narrow reward functions, and that may not capture this imperative to survive and reproduce. Biological systems also take much longer. It's a whole generation to see what the effects of an alternative way of organizing society are. So this creates opportunity and risk because AI hierarchies can adapt rapidly, but they also are less stable without the right incentives. The memory structures within these are different because AI agents have a perfect recall of all the interactions that they've had in these simulations unless they're programmed otherwise. Now, biological organisms tend to selectively remember and forget things. So AI hierarchies can become very rigid because of this. They have a complete historical record. They don't assume that there's been any change in the other agents that they're interacting with. Embodiment makes a difference too. Biological systems have to deal with physical constraints, but virtual AI agents can develop organizational patterns that are physically impossible. Now, more recent work is showing that when researchers scaled these LLM-based agent collaboration to over 1,000 agents, they found collaborative scaling law. Performance improves predictably as the number of agents you're deploying increases, but group-level intelligence seems to appear earlier than it does in individual neural networks. Individual neural networks need huge amounts of computational resources before new abilities suddenly appear, but multi-agent systems show this with around 100 agents. So what does this imply? I think in a business context or anywhere, if you're deploying agents, and we're seeing this, it's a lot better to have a lot of dumb agents than one super smart, high-powered agent. 1,000 agents don't need 1,000 times the intelligence. They tend to pool and structure what they already know together, and that results in this specialization. At the 10,000 agent scale, which was achieved in a 2025 simulation, genuinely society-like phenomena started to emerge. The agents developed social norms through their interactions. They formed whole relationship networks, and they showed emotional contagion spreading through clusters. And they organized collective activities without anyone directing them from above. That'd be the equivalent of the department lunch hour or something. So AI agents do give up control, and they put themselves below others in a hierarchy, but they have different mechanisms than human submission does. In leader-follower formations, subordinate agents deliberately hand over their decision-making authority to the coordinators, to the leaders. They estimate what the leader values, and then they adapt their own strategies to complement that, rather than competing with it. Now, this acceptance of guidance isn't something programmed. It's emerging through reinforcement learning when agents figure out that coordination improves their outcomes. In many cases, coalition formation, where agents surrender individual autonomy for the group's benefit, accepting group decisions that might conflict with their personal beliefs or assessments. The subordination seems to be more rational than emotional compared to biological systems like human systems. Animals show stress responses to being dominated, but AI agents just adapt their strategies. It's not clear if this represents true subordination or just a strategic coordination. So that gets into philosophy, which we cover on this channel too. And if you're liking this content, I'd appreciate it if you push the like button. It helps the channel grow a lot. One thing that's consistent in all the studies I looked at was that network position matters as much as competence for a leader to emerge. Agents with the broadest information networks, or who are sitting at the center of passing messages between different agents in a sort of friendship or social network, naturally became coordinators, not dependent on their raw capability. Bridge agents that connected different subgroups together would assume leadership roles by controlling the flow of information. Now, this is different from a pure competence-based leadership. An agent with moderate capability, excellent network position, can coordinate more effectively than a highly capable but isolated agent. But maybe that's also human, right? Is your boss smarter than you are? Now, this does mirror human organizations where a charismatic communicator can lead, despite the fact that he or she isn't the most technically skilled person in the room. We also saw a dynamic role assignment that was based on communication patterns, and it was a middle ground between the rigid hierarchy and complete equality. Agents can shift between leading and following based on what the task at hand is and what information they have access to and the current state of their network. So the most profound insight that I got from all of this reading was that hierarchy isn't hardwired into biological or artificial systems necessarily. It seems to emerge as a solution to the problems of coordination when you get a large enough group together trying to achieve some task. Now, this does seem to suggest that hierarchy represents a convergent organizational strategy from a lot of different perspectives. That could be from humans, animals, or AIs. it leads to much more efficient decision making. So understanding these patterns is going to be pretty important because AI systems are going to grow from research demonstrations to being deployed inside infrastructures and companies that need robust, aligned, beneficial organizational structures.